Welcome to Cadence tutorial. I am Madan Kumar Jha and today I am going to explain how to design a NAND gate using Pass Transistor Logic. Okay, so before proceeding this video, you should once watch the video how to design 2:1 mux using NMOS based Pass Transistor Logic. I have explained it in my previous video. Okay, so go there. So in this video, I will explain how to design this. So basically the output of a 2:1 mask is y equals to s bar d0 plus s into d1. So if I will provide a signal a to s and b to b bar to d1, then it will be converted as a bar into 1 plus a into b bar, which will be converted to a bar plus b bar. Okay, because a bar plus a b bar equals to a bar plus b bar, and this is a bar plus b bar will be a plus b whole bar. Using De Morgan law, I can write a bar plus b bar equals to a into b whole bar, that is NAND operation of a and b. Okay, so uh, for realizing this in Cadence, what I have to do, I have to provide a signal b bar here, which is a form of a pulse. So that is 1.8 and b1 and b2 is 0, and this is DC voltage which provide 1.8 volt always to D0 pin, so it is logic high. Okay, then this is A, this is B bar. So I want to see A into B whole raised to bar in the output section, but I do not have pin B here. So in output section, uh, I will invert this B bar. Okay, so I'm going to launch this. Go to edit, then set up transient time to 200 nanosecond, then in go to moderate. In output section, go to schematic, then select A and B bar and Y. Okay, so this is our output. Now everything is fine. Go to setup, go to model library and check once only GPDK 180 nanometer is select, so no need to worry. Then run the simulation. Okay, split the graph and check whether it is working or not. So this is basically B bar, so the invert form of B bar will give B. So when A is 1, B is 1, so 1 into 1 is equals to 1. So inverting form of this will be 0, so it is fine. When B is 1 and A is 0, so its invert will be 1, so it is 1, so it's working fine. When A is 1, B is 1, B is 0 because B bar is 1, so its output will be 1. Okay, when A is 0 and B is also 0, so 0 into 0 is 0, so its inverting will be 1, so no need to worry, it's okay. When A is 1 and B is also 1 because B bar is 0, so 1 into 1 is 1, so its inverting will be 0, so this is working fine. Okay, you can see this is working fine. So this is the output of a AND gate, NAND gate. Okay, fine. Now again I am going to make the circuit of NOR gate. Okay, so first for that I am again going to explain how to design a NOR gate using Pass Transistor Logic. So this is the Pass Transistor Logic based NOR gate. So what I have to do, I have to give A bar to D0, 0 to D1 and B and B bar to select line. So basically actually I have provided A here and A bar here, so no need to change that things. And the signal will be B bar here if I will change this. Okay, so go to cadence, then in output section, actually I have to provide 0 to D1, so provide 0 here, 0 volt, so connect it with ground, just connect it with ground. W, connect this. Okay, then this is our B and B bar, so if I will make it A and A bar, so no need to worry. Okay, so it is A and A bar, it's fine. Then D0 should be A bar. Okay, so D0 should be A bar, so now in my schematic D0 should be B bar. Okay, so change this input to B bar, so press Q, change its name to B bar, and its name to D0 or D1. Okay, press Q, change it to D1, enter. Now everything is okay. So the output will be basically NOR of A and B, so A plus B whole day to bar. Okay, now go to launch, then ADL. Actually I think ADL is already open, so close it. No, go to launch, then ADL, then change this stop time to 200 nanosecond, then go to moderate, click on OK, go to setup, from design select A, B bar, Y. Again I am going to remind you that this is B bar, not B. Okay, so in output section I have to invert this in my visualization. Okay, go to output. Okay, then run this simulation. So basically I haven't check and save this, close, and there are some error. No, so what kind of error I am getting? This pin is D1, so it gives error. It should not give any error. Okay, netlist in the field, because no, the netlist I mean all. What is error? The cell view cadence schematic has modified in the last ability to correct and check. Okay, so I'm going to delete this pin. This is useless here. Okay, so no need to see this. Okay, going to check and save. Now run this. Delete. Now you can see this is B bar. Okay, so I haven't provided any pulse to B bar, so delete this. Go to I, then here B pulse, select voltage 1 to 1.8 volt, 1.8 volt, and voltage 2 to 0. Then it's period to let's take it 10 nanosecond. I think 10 nanosecond is that, so 20 nanosecond, and it should be 10 nanosecond because I want uniform square wave. So hide this, use it here. Okay, then check and save. Now close this and done. Now you can observe here, so it is B bar, so I have to interpret it as B, so I have to change this 0 to 1 and 1 to 0. Okay, so when, let me make it more thicker and solid. Okay, so style solid and it is okay. So when it is 1, it is also 1. So A and B, when A and B both is 1, so 1 plus 1 is 1, so it will be 0. When A is 0 but B is here 1, because B bar is 0, so 0 plus 1 is 1, so the inverting form of 1 is 0, because this is NOR. Again 1 is B bar, so B is 0, so 0 plus 1 is 1 and the invert of 1 is 0, so it's okay. Now this is 0 and the invert of B bar is 0, so B is 0, so 0 plus 0 is 0, so the invert of 0 is 1, so it is 1. So the NOR gate is working fine, so no need to worry. Okay, now it's time to implement XOR gate. Okay, so let me check once. Okay, so again go to schematic of XOR gate. If I want to draw a schematic of XOR gate, so first I have to see how can I implement do. So when I will provide a signal A to the select line and B bar to D1, then A B bar plus A bar B, so it will gives Y equals to B A bar plus A B bar, so it will be XOR operation, so no need to worry. So if I will provide a signal B here, then inverting form of B is provided to here, and this is okay. So again go to A B. Okay, now delete this. So if this is A, delete this again. Okay, so if this is A, so here I have to use B bar. So B, generate a pin which will be input B bar, sorry, B bar. Okay, go to hide, then use this pin here, then press W, connect this pin here. Okay, now this is A bar, so I have to again generate a pin which will be B, and it should be input pin, so press it here, then go to W. Okay, and copy this B pulse and use it here, so press W again, connect this it with this. Okay, now I have to change the pulse waveform. I have to invert it because this is B bar, so again press Q, go to properties, and then change this to 0 and this to 1.8 volt. Okay, now everything is correct, enter. Then you can see here this is the inverting pulse form because B1 is 1.8, B2 is 1.8 here. Okay, so check and save, go to launch ADL. Actually ADL is opened here, so no need to save it. Go here. Okay, launch ADEL, then edit, set transient stop time to 200 nanosecond, then go to moderate. Okay, then again go to output section, edit, from design select A B. Okay, then okay, again Y should also select. So okay, then everything is fine, run this netlist. So this is the output. So when A is 1, B is 0, it is 1. When both is 0, it is 0. When both is 1, it is 1. Okay. So what a XOR gate output is, when it is same, it should be 0, because 1 into 0 plus 0 into 1 should be 0. And when it is different, it should be 1. So you can see, when it is 1 it is 0, so it is different, so it is 1. When both is 0, so it is 0. So this is the different, so it is 1. This is different, so it is 1. Again here it is different, so it is 1. But when both input A and B is same, then it is 0. So my XOR gate is working fine. Okay, this is the output of XOR gate. Here voltage drop of BTS again occur, because this is pass transistor logic based XOR gate. Okay, now I want to simulate the XNOR gate to Cadence. So for that I am going to see the circuit diagram of XNOR gate. So this is the XNOR gate circuit diagram. Here what is different from the previous circuit, that it is, if it is A then it is B, if this is A bar then this is B bar, then it will be AB plus A bar B bar. So AB plus A bar B bar is basically XNOR gate. Okay, so nothing should be changed in a schematic. What should I change? I should change only A and B bar pin location. Okay, so delete this and this, just drag this pin to here and drag this pin to here. So it will be the schematic of a XNOR gate. Okay, then press W and wire it. Okay, now check and save and run this simulation. Now you can see here, when the both input is 1, it is 1. When both input is different, then it is 0. Okay, so yes, XNOR gate output is, when both input is different, then the output will be 0, and when both input will be same, then output will be 1. So it's working fine. Okay, so this is the schematic of XNOR gate, and this is the output of XNOR gate. Okay, so from this video, after this video I am going to complete the PMOS and NMOS pass transistor logic based circuit. So I have completed all circuit uh, which is required. In next video I will be explain about CMOS inverter. Okay, and how CMOS inverter works will be seen in that video. So it's all about pass transistor logic in this video. Thank you.